Morning students, welcome to online class DO Nalgonda. After complete the first section, next we are here to in the second section. In the first section, what did we learn means spectrum, electromagnetic spectrum, Bohr's atomic model of hydrogen atom and quantum mechanical model of atom and orbital structures. Okay, and next quantum numbers. Okay, what are quantum numbers means? By using these quantum numbers, we describe the atom. We describe the electron in the atom. Okay, so by using this there are four quantum numbers is there. Okay, by using these four quantum numbers, we can describe the and we can address the electron in the atom. Where the electron is located in the atom, the exact place of the electron in the atom we can set by using this. We can say by using this four quantum numbers. Okay, what are the four quantum numbers means? First one is principal quantum number. Okay, first one is what? Principal quantum number. So this is proposed by Bohr. It is denoted with the small n. Okay, this principal quantum number is explained and states the size and energy of the orbit. Okay, size and energy of the orbit. The n values are positive integers. They are 1, 2, 3 dash dash. If n equals to 1 means the electron in the first shell. If n equals to 2 is there means the electron in second shell. If n equals to 3 is there means the electron in the third shell. Okay, so suppose around the nucleus, first shell, second shell and third shell. Okay, shells is there. Okay, the electron in the first shell, the n value is 1. N equals to 1. So here the orbit size we can say how it means the nucleus to center of nucleus to first shell distance. So it represents the size of the orbit, and in the electron, if it is in the first shell, the electron has energy is E1. So by using the n value, if n equals to 1 means first shell, by using this n value we say the size of the orbit and energy of the orbit. For example, if n equals to 3 is means n equals to 3 means that is a third shell. So we say the size of the orbit we can say, and energy of the orbit we say. Okay, so by using the principal quantum number is proposed by Niels Bohr and it is denoted with the small n. The values are represented 1, 2, 3 dash dash. If n equals to 1 is the first shell and n equals to 2 is the second shell and n equals 3 is the third shell. So these shells are represented, this n values are states the size and energy of the orbit. Okay, so this is the first quantum number, that is the principal quantum number. And second one is angular momentum. Okay, second one is angular momentum quantum number. It is represented with the L. It is denoted by Sommerfeld. Okay, second quantum number is angular momentum quantum number, and azimuthal quantum number is also we say. Okay, angular momentum quantum number or azimuthal quantum number. This azimuthal quantum number or angular momentum quantum number is proposed by Sommerfeld and it is denoted with the small l. The L values are for given n value. L values are for given L value is L equals to 0 to n minus 1. Okay, for given n value. Okay, for given shell, how many number of L values is there means 0 to n minus 1. For example, n equals to 1. Okay, first shell. So L value how many is there? 0 to 1 minus 1 means 0. So for n equals to 1, the first shell the L value is 0. Okay, so these are this principal angular momentum quantum number is states the shape of orbital. Okay, this L quantum number is explains the shape of the atomic orbital. The shape of the atomic orbitals, the values are from 0 to n minus 1. For given n value, the number of L values is 0 to n minus 1. For example, if n equals to 1 is means L equals to 0 to 1 minus 1 means 0. So, L equals to 0. For n value, L value is 0. So, it is represented with S. So, the first shell S orbital is 1s. So, the first shell L equals to Z means that is the S orbital. S orbital is the means that should be the 1s. If n equals to 2, L values are 0 to 2 minus 1. Okay, 0 to 2 minus 1 is 1. Okay, 0 and 0 after 1. 0, the next one is 1. Okay, and next one you see 2 minus 1. Okay, 2 minus 1 means up to 2 minus 1 we have tried. So, the values how many for n equals to 2 means for L value 0, 1. So, if L equals to 0 means it is S orbital. So, second shell S orbital is represented as a 2s, and if L equals to 1 it is the P orbital. The second shell P orbital is represented as a 2p. Okay. For example, it stays the shape of orbital L values are 0, 1, 2, 3 dash dash up to n minus 1. Okay, up to n minus 1. If L equals to 0 is the means that is the S orbital. If L equals to 1 means that is the P orbital, and L equals to 2 is the means that is the D orbital. Okay. Next L equals to 3 means F orbital, so on. Okay, so this like the S and P and D orbitals are there differ with the shapes. So L values are 0, 1, 2 dash dash n minus 1 up to n minus 1. So for given n value, how many number of L values is there means for n value 1, n equals to 1, L equals to 0. Okay, L equals to 0, it is the first shell L equals to 0. L equals to 0 is represents L equals to 0 means that is S orbital. First shell S orbital means it is written as a 1s. And next is L equals to 0, 1, second shell L values are 0 to n minus 1 and 2 minus 1 and 1 and 0 and 1. L equals to 0 means S orbital, second shell S orbital is 2s, and L equals to 1 means P orbital, second shell P orbital means it written as a 2p. And next n equals to 3, L values are 0, 1, 2. 2 means 3 minus 1 now. 2 means what? 3 minus 1 and n minus 1. So 3 minus 1. So up to n minus 1 only we have to take the L values for given n value. So L equals to 0, 1, 2 means L equals to 0. L equals to 0, it is the S orbital. For third shell S orbital is it is written as 3s. And next L equals to 1, it is the P orbital. Third shell P orbital is written as a 3p, and L equals to 2, it is D orbital. Third shell D orbital is written as a 3d. Okay. So this like the angular momentum quantum number or azimuthal quantum number. The azimuthal quantum number is proposed by Sommerfeld. It is represented with denoted with small l. The values are from 0 to n minus 1. This Sommerfeld atomic mode, this Sommerfeld proposed the azimuthal quantum number. It states and it explains the shape of orbital. So L equals to 0 is the means the shape of orbital is S orbital, spherical shape, and L equals to 1 is the means that is the P orbital. P orbital shape is dumbbell, and L equals to 2 is the means this is the D orbital. This D orbital shape is double dumbbell, and n equals 3 F orbital. So that shape is the triple dumbbell. So here next for n values, for given n values, how many L values is there means n equals 1, L equals to 0, 1 minus 1. So 0, only one L value. So that is 1s. N equals to 2, L have 2 values 0 and 1. For 0 s orbital, second shell s orbital means 2s, it written as a, and L equals to 1 p orbital, second shell p orbital is written as a 2p, and n equals to 3, it has a 0, it starts from 0 up to n minus 1. Okay, start from 0 and up to n minus 1 means 0, 1, okay, 3 minus 1 means 2, so last 2. L equals 0, L equals 1 and L equals to 2. L equals 0 means 3s and L equals 1 means 3p and L equals 2 means 3d. So, this like angular momentum quantum number is set. And the third one is magnetic quantum number. Okay, magnetic quantum number is proposed by Landau and it is represented with a small m. The values are start from minus L to plus L. Okay, for given L value, the values are minus L to plus L, including 0. Okay, including 0. Okay, suppose here, what is magnetic quantum number means it states that the magnetic quantum number states that orientation of atomic orbital by external magnetic field. Orientation of atomic orbital by external magnetic field. Okay, so if any atomic orbitals are affected by the external magnetic field, so they are oriented in a directions, different directions. Okay, for example, if L equals to 0 means that is the s orbital. This s orbital is a spherical shape. Okay, this spherical shape, it can't oriented in other any direction. It is a spherical shape means it is only s, that is s. And L equals to 1 means p orbital. Okay, it is the dumbbell. Okay, dumbbell shape, it can oriented into 3 different directions, px, py and pz. Okay, so L equals to 0 means m value only 1, that is should be 0, and L equals to 1 means that is the p orbital, dumbbell shape, it can oriented, it can moving in a x axis and y axis and z axis. So, they are the 3. So, m has only 1 in the first L equals to 0, only one orientation, that is 1, but in the second case p orbital the orientations are 3, px, py, pz. In L equals to 2, the d orbitals are double dumbbell. Okay, the orientations are occurred in last class we learned dxy, dyz, dzx, dx square minus y square, dz square. Total 5 orientations are occurred. Okay, if f orbitals is there means they are oriented into 7 directions. So, this like L equals to 0, s orbital, it oriented only one direction, it is spherical, so it is not oriented, that is only one m has, it has only one m value. L equals to 1 means p orbital, dumbbell shape, px, py, pz orientations are occurred, 3 values for L equals to 1. L equals to 2 means double dumbbell, it has 5 orientations are occurred, 5 values for m value, 5 values for m. Here you see if L equals to 0, that is the s orbital, m values are minus L to plus L. Minus L to plus L means minus 0 to plus 0. Minus 0, 0, plus 0, all is 0 only. Okay. So, L equals to 0, that is s orbital, for m value is what? 0. If L equals to 1, that is the p orbital, m has how many values? 3 values. What they are? L equals to 1 means p, m values are minus 1 to plus 1. Minus 1 to plus 1, in number line minus 1 to plus 1, in middle 0 is also there. Minus 1, comma 0, comma plus 1. So, px, py, pz. So, that's like 3 values for m. And next to L equals to 2, d, double dumbbell. Okay. So, here m values are from minus 2 to plus 2. on number line you see -2 to +2, -2, -1, 0, +1, +2. So total how many values is there? 5. So 5 oriented orbitals, 5 values is there, -2, -1, 0, +1, +2. So this is the magnetic quantum number. The magnetic quantum number proposed by Landau, -L to +L, the m values for given L value. This states that the orientation of atomic orbital by external magnetic field, the values are for L equals 0, for m is also 0. L equals 0, s orbital is m is also 0. L equals 1 means p orbital, that is value is -1 to +1, and L equals 2 means that is the d orbital, -2, -1, 0, +1, +2. Okay, and the last one is the spin quantum number. Okay. In spin quantum number proposed by Uhlenbeck and Goudsmit, it is represented with the small s, and these values are only 2, they are plus of and minus of. Okay. What is spin quantum number states? The spin quantum number states the spinning of electron in the orbital. Okay, as a clockwise or anti-clockwise. Okay, clockwise or anti-clockwise direction. If clockwise direction, the s value is plus of. If anti-clockwise direction, the s value is minus of. Okay, the spin quantum number is proposed by Uhlenbeck and Goudsmit. It is represented with the small s. The values are plus of and minus of, and this is states that the spin quantum states that the spinning of electron around the nucleus in the orbital, either clockwise direction or anti-clockwise direction. Okay, if clockwise direction, the spinning is occurred, the s value is plus of. If anti-clockwise direction, the spinning is occurred, s value is minus of. So by using these 4 quantum numbers, we say the exact position of electron in the atom. Okay, so next 2 applications by using these 4 quantum numbers, applications is there. The applications after completing electronic configuration I will say. Okay, you keep it in this mind. Okay, first you see my electronic configuration. Okay, electronic configuration means the distribution of electrons in the atomic orbitals around the nucleus, that distribution systematically in the atom, that is considered as a electronic configuration. The systematic arrangement of electrons in the atomic orbitals is considered as a electronic configuration. Okay, so the electronic configuration, to write the electronic configuration, there is a Euler diagram is there, 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s, 2p, 3p, 4p, 5p, 6p, 7p, 3d, 4d, 5d, 6d, 4f and 5f. Okay, so next you draw the arrows. First shell is only one shell. It should be the orbital. It should be the orbital, that is the 1s. Second shell has 2 subshells, that is 2s and 2p, and third shell has 3 subshells, 3s, 3p, 3d, and fourth shell has 4 subshells, 4s, 4p, 4d, 4f. Fifth shell has more, but up to until 118 elements, so this is enough. This Euler diagram electronic configuration up to we are filling this up to 8s is enough. If future upcoming elements is there, means future electronic configuration further is invented. So now here the Euler diagram 1s, 2s. First we have to filling the electrons in the 1s first shell. So there is the filling the electrons in the atomic orbitals. There are the rules is there. Okay. First one is half-wave principle. Okay, what is half-wave principle means? The electrons are filled in first low energetic orbitals, then it is enter into the next energetic orbital. Okay, so how we can find out the low energetic orbitals means if any atomic orbitals is there means the n plus L value, okay, n plus L value is there means that is has a by using the n plus L value we have to identify the energy of that atomic orbitals. Okay, so here 1s and 2s you have observed, 1s n plus L value and 2s n plus L value is C. What is n shell number? Okay, what is n shell number and what is L means s orbital L value is always 0. S orbital L value is always 0. So n plus L value means here sigma, here this 2, one is letter and one is number is there. This number is represents the shell number and this letter is represents the shape of the orbital. S is M is spherical, P is M is dumbbell and D is M is double dumbbell. S orbitals always L value is 0 and P orbitals always 1 and D orbitals is means L value is 2. So this like 1s and 2s you see. In these two cases n plus L value, n value for 1s is 1 and L. S orbital means it is 0. 1 plus 0 the value is 1. Here 2s you see, 2s n value is 2 and s orbital means L value is what? 0. 2 plus 0 means 2. So the n plus L value for which orbital is less? 1s is less. So that's why 1s is less energy orbital than 2s. So among these all atomic orbitals, which is the lowest energetic orbital means 1s. So first these arrows are represented, this first arrow by top to bottom the arrows are increasing, the energies are increasing. So first arrow it is crossing the 1s, so it has a less energy than other atomic orbitals. So the energetic order we have to write it as a 1s less than, 2s less than, 2p less than, 3s less than. So first line. Next second arrow is going to 2s and third line is going to 2p, next 3s and fourth line is 3p, 4s. So this like the energetic order is 6 is so on. Okay. So this like the energetic order we have to write by using this Euler diagram. So the top to bottom the energy is increases. So here the first arrow is going to the 1s, so it has a less energy and 2s, next one is second line is going to 2s and third line is going to 2p and 3s, 2p, next 3s, 3p, 4s, 3d, 4p, 5s. So this like move on the energetic orbitals. So first electrons we have to fill in the lowest energetic orbital, then next energetic orbital. So the half-bow principle is what means the electrons are first fill into the lowest energetic orbital, then it is entered into the next energetic orbital. So if suppose two atomic orbitals is there means we can find out by using the energy, by using the n plus L value. N plus L value, n is 1 for 1s, L is s orbital means L value 0. 2s n plus L value, n is 2 and L is s orbital means 0. So 2. So n plus L value which is less? This one. So it is a less energy than 2s. Okay. If suppose (2p) and 3s you are observe, 2p n plus L value and 3s n plus L value you are observe. Okay. Here 2p, n is second shell, L is p orbital means L value is what? 1. N equals to 3 shell number and L, s orbital means L value is what? 0. It is 3 and it is also 3. If n plus L value is same, you consider the n value which has a less n value, that has a less energetic orbital, and next another one, next energetic orbital. So here 2p and 3s, okay, both are same n plus L value, but which has a less n value? 2. So that's why this 2p's we have to first fill, the next one is the 3s. So this like first we have to fill in the less energetic orbital, then it is entered into the next energetic orbital. So how we can find out the less energetic orbital means by using the n plus L value. If n plus L value is same, you consider the n value. Okay. If n value is also same, they are the degenerate orbitals. Okay. They are called as a degenerate orbitals. What are degenerate orbitals means? The orbitals which have a same energy. Okay, so we have to equally distributed. Same energy unnappudu mana electrons we have to equally distributed. So that is the half-bow principle. So okay, what is Wund's rule means? the pairing of electrons is occurred in the degenerate orbitals all equally shared, then it is paired. Okay, the pairing of electrons in the degenerate orbitals are after complete equally sharing, then it is paired. Okay, for example 2p you see there are the 3 orbitals, there are 2px, 2py and 2pz. Okay, 2px, 2py, 2pz, 3 orbitals is there. In this 3 orbitals n plus L value and n plus L value and n plus L value C. N plus L value, n is second shell 2, it is p orbital 1. N is second shell 2 and it is p orbital 1. N is second shell 2 and it is p orbital is 1. So these all are 3 values same. N plus L value is 3. All these 3 orbitals are n plus L value is 3. Next you consider n value. Okay, here n value is 2, here n value is 2, here n value is also 2. So the 3 orbitals n plus L value is same and n value is also same. So what we call these orbitals means degenerate orbitals. These degenerate orbitals have same energy. So this degenerate orbitals while we are filling, if suppose 2p4, in this 2p orbitals 4 electrons is there means don't fill, first is completed, next second shell, it is the wrong. First each atomic orbitals we have to fill one electron, then the fourth electron is pairing start with the first orbital. Okay, so this like if suppose 2p5 is there means first 3 electrons are off filled, next fourth electron paired in the first, and any atomic orbitals we can paired, all are degenerate orbitals. First linely is there means first 3 atomic orbitals, first 3 off filled, in the next fourth electron is paired and fifth electron is paired. One empty electron is there. Okay, so this is the Hund's rule. What is Hund's rule means all degenerate orbitals are first off filled, then they are paired. Okay, all degenerate orbitals are first off filled, then paired. Okay, so this is the Hund's rule. Okay, and next last one, Pauli exclusion principle. Okay, next one is what? Pauli exclusion principle. What is Pauli exclusion principle means no 2 electrons possess same 4 quantum numbers. Okay, no 2 electrons possess 4 quantum numbers same. Okay, so all electrons are differ with their any one quantum number. Okay, all electrons they are addressed by the 4 quantum numbers differ with their at least one quantum number. Okay, that rule is that principle is considered as a Pauli exclusion principle. For example, hydrogen you see 1s1. Next you going to the helium, 2 electrons, 1s2. So here 1s2, 2 electrons we have to fill. One is clockwise and one is anti-clockwise. So this electron and this electron you see, this electron n value is n and shell number. What is this shell number? 1s. This one represents the shell number, first shell. N equals to 1. L equals to shape of the orbital. S is the shape of orbital. S is spherical, means S value is m, is that L value is 0. And next you going to m. If L is 0, m is always 0. And next x. It is the upward arrow, means represents the clockwise direction. So S value is what? Plus of. And next here you see n. Same, here is also 1s orbital. This electron is also in 1s orbital. So n value is 1, shell number 1, and L is also S orbital, means spherical shape, that is the L value is 0, and m is L is 0 means always m is also 0, and S is, it is a downward arrow, it represents the anti-clockwise direction, it represents minus of. Okay, plus of and minus of. They are varies with the spin quantum number. So in the same atomic orbitals only these 2 electrons, but the 2 electrons are varies with their spin, clockwise and anti-clockwise. So this like no 2 electrons possess same 4 quantum numbers. Okay, following these 3 principles, our principle, Hund's rule and Pauli exclusion principle, we have to distribute the electron in the atomic orbitals. Okay. So next you have to write up the electronic configuration. First you see hydrogen, it has 1 electron. Neutral atom is the means atomic number is the number of electron. Okay. If neutral atom is neutral, the number of electrons is equals to atomic number. Okay. So in hydrogen atom, how many electrons is there? 1 electron. That 1 electron is going to according to our principle, it is going to lowest energetic orbital. Which is the lowest energetic orbital in this order? This one. So first we have to fill S. 1s. Okay, you see ma 1s, s orbital is only 1, it can oriented. So s orbital is only 1, p orbitals are 3 and d orbitals are 5. So in s orbitals we fill 2 electrons, one is clockwise and one is anti-clockwise. P orbitals, total 3 p orbitals is there, px, py, pz. Each px and py, pz we have to fill the electrons, one is clockwise, one is anti-clockwise, one is clockwise and anti-clockwise. Total number of electrons we fill in the p orbital is 6 and d orbitals total 5. Okay, d orbitals are total 5, dxy, dyz, dzx, dx square minus y square and dz square. Total first half filled according to Hund's rule, then next to paired. Clockwise half filled, next to anti-clockwise paired. So it is total 10. So f orbitals is means 14. Okay, s orbital is accommodated by 2 electrons, one is clockwise and one is anti-clockwise. P orbitals are 6, 3 orbitals px, py, pz, 6, 3 are clockwise and 3 are anti-clockwise. D orbitals are total 5 d orbitals. Each d orbital, one is clockwise and one is anti-clockwise, total 10 electrons. And f orbital is 14, 7 orbitals is there, 14 electrons we can fill in the f orbitals. So this like if hydrogen is there means 1 electron, it has 1s1. First 1s, why we are entering into the only 1s orbital means according to our principle, first electron is entering to the lowest energetic orbital. So that's why in the this is the energetic order, which is the lowest energetic orbital 1s. So first we have to complete the 1s, next we complete the 2s, next it complete to 2p. So that's like hydrogen 1, 1s1, helium you see. Helium atomic number 2, it has 2 number of electrons, they are written as a 1s2. Okay, NLX method, N is the shell number, L is the shape of the orbital and X is the number of electrons in the orbital. Okay, N is the shell number, principal quantum number, L is the azimuthal quantum number. The azimuthal quantum number represents the shape of the orbital, S or P or D. And x is the number of electrons in that particular orbital. This particular orbital lo any number of electrons untayi, it is represents that x, and x is the number of electrons. Okay, here hydrogen is 1, it is written as a 1s1, and next to helium it has 2, 1s2. First shell s orbital has 2 electrons, the 2 electrons. Okay, and next to lithium 3 electrons, atomic number 3, neutral atom is the 3 number of electrons. So there is 1s2. Okay, the third electron enter into the next atomic orbital. Why? Because this 1s is completed. S orbital is only 1, that is one is clockwise and one is anti-clockwise. After next it is enter into 2s. Then rod electron is enter into 2s1. So we can write this is an boxes type. In this 1s box, 2 electrons, one is clockwise and one is anti-clockwise. And this one is 2s. Only 1 electron is there means that should be the clockwise. If 2 is there means one is clockwise and one is anti-clockwise. And next to beryllium, 4 number of electrons, 1s2, 2s2. Here clockwise, anti-clockwise, 2 electrons, clockwise and anti-clockwise. Okay. And next to boron, 5 electrons, 1s2, 2s2. Okay. So here 4 electrons completed after, the 5th electron is entry into the 2p. Why? Because 2s is completed, s orbital only 1 orbital, it is 1 clockwise and 1 anti-clockwise, it can accommodate. Next electron is entering into 2p orbital. So the 5th electron is entering into what? 2p orbital. So here one is clockwise and one is anti-clockwise, clockwise, anti-clockwise. 2p orbitals are total 3. Okay, 2px, 2py and 2pz. Okay, so here only 1 electron is there, that is in 2px, clockwise direction. Okay, if suppose carbon you see total number of electron 6, 1s2, 2s2, 2p2. So here you see according to Hund's rule, 2px, 2py, 2pz, 3 are the degenerate orbitals the second electron in the 2px, 2py, 2pz, it is not paired in the 2px. Why? Because all are degenerate orbitals according to Hund's rule, all are equally sharing off field, then it is paired. Okay, so 2px1, 2px1, 2py1. And next nitrogen, you see atomic number 7, it has a 3. Okay, 3 number of electrons. So 3 is there means 3 orbitals are equally shared by clockwise direction. Okay, 2p3. Off field is the more stability. Off field is get extra stability to the atom. Okay, and next oxygen, 8 number of electrons, 1s2, 2s2, 2p3. At here you see it is s orbital and it is the p orbital. S orbitals only 2 it can accommodate it. P orbital 6 it can accommodate it. So 2px, 2py, 2pz. So 4, 8, 1s2, 2s2, 2p4. So 2p4 means first 3 off field, next one is paired by anti-clockwise direction. Okay, and next to fluorine, and this one is the 9, the atomic 5, and this is 5. And next, if it is neon, atomic number is 10, this one is 6. It is going to completed field. Okay, 1s2, 2s2, 2p6, total 10 electrons. Okay, if suppose sodium, total 11 electrons, 1s2, 2s2, 2p6, the 10th electron, the 11th electron, total 10 electrons completed, the 11th electrons arrangement, the 11th electron is not entering into the 2p. Why? Because it is already completed. The next electron is entering into the next energetic orbital is 3s. So the electron is entering into 3s. Okay, so S is only one atomic orbital. It accommodates only 2 electrons. 3s 1. 11th electron up to here 10 over. Next the 11th electron into 3s 1. The 3s 1 electron should be clockwise. Okay, so this like any atomic number, if it is given, the atomic number, if it is neutral atom, the number of electrons is there. The number of electrons we have to fill in this atomic orbitals. Okay. For example, last one you see chromium atomic number is 24. So 24 electrons we have to fill in the atom. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. How it will be means s orbitals is accommodated by only 2, p orbitals are 6 and d orbitals are up to 10. So total 24 is there, 1s2, 2s2, 2p6 up to 10 is over. Next to 12, 18, 20. So the remaining 4 electrons is entering into 3d orbital. So the 3d orbitals are here at the exact bottom. You have to write the box. 1s 2 electrons, 2s 2 electrons, 3p 2p and 3s 2 electrons and 3p 3 boxes, 3 orbitals and 4s and the 3d. 3d has 5 atomic orbitals. 3dxy, 3dyz, 3dzx, 3dx square minus y square, 3z square. So this 4 electrons we have to fill in. First 5 off filled, then it is paired. So here only 4 is there. So 4 atomic orbitals are got 1 electron. So that is clockwise direction. So this like we have to write the electronic configuration of any atom by using the Maillard diagram, that energetic order. Okay. So in this lesson, in this section, what did we learn means the quantum numbers, the 4 quantum numbers. Once you see quantum numbers also we write any, if suppose here, so suppose argon you see 18, 1s2, 2s2, 2p6, 3s2, 3p6. Okay. Okay. If suppose 3p6, the 18th electron NLMS values we have to write. Okay. So in the board exams, they may ask quantum numbers of a particular electron. Okay. In the argon, the 18th electron The 18th electron NLMS values you have to write. 18th electron means 1s2, 2s2, 2p6 up to 10 over, and it is 12 over. 12 means 17 electrons, this like it has arranged. First in this 6 electrons, how we have to fill in the 6 electrons in this orbital? First 3 off filled. Okay, 3p3 is means up to 3 off filled. Next fourth one is in this paired, fifth one is in this paired, and sixth one is in this paired. So total the 18th electron means 3p6. This electron is the 18th electron. This 18th electron NLMS values. N value, shell number. What is this number? 3, third shell. So N value is 3. And this electron is present in the p orbital. So L value is always L value is become 1. And next, if L is 1, M has a 3 values. -1, 0, +1. Okay, -1, 0, +1. If electron is in this orbital, M value is -1. If electron in this orbital, M value is 0. If electron in this orbital, M value is +1. So M value is +1. And the spin quantum number S. It is clockwise, it is anti-clockwise. Last electron means this electron, how it will be? It appears as it is anti-clockwise. So S is anti-clockwise, that is -half. So this like any electron NLMS values you can write by using these 4 quantum numbers. If you are aware of these 4 quantum numbers, you can easily write. N is the shell number. Okay, so if orbital is M, is orbital N, this is L, and this is the number of electrons. Okay, and N is this is represents the N value. N equals to 3. L is it is S orbital at 0. If p orbital is 1 and d orbital is 2. M values means S is M means only 1. M is 0. If L is 0, M is always 0. Per p orbital, L equals to 1 means it has 3 values. -1, 0, +1. If electron in this last atomic orbital, M value is +1. S is M means if electron is clockwise or anti-clockwise. Clockwise is M means +half, anti-clockwise is M means -half. So this like any electron address and any electron position we can exactly say by using this 4 quantum numbers. Okay, electronic configuration and the rules following while distributing the electrons in the atomic orbitals. Okay, thank you.